Welcome to Kothait channel. Let's take a look at heart disease prediction machine learning model which we are going to build from scratch in this video. So here is the heart disease predictor web application looks like. So here we have to choose the gender. Let me choose the female. Age is 55. Current smoker, yes, 1. Okay. Number of cigarettes per day, 40 cigarettes per day. And is patient on BB medication? Yes. Patient had a stroke? Yes. Hypertension status? Yes. Diabetes status? Yes. And cholesterol is just take 200. Systolic BP is 180 and dialytic 100. BMI is 50 and heart rate 120. Glucose levels 180, 170. Let's predict. So patient may have heart disease. Okay. So if I reduce couple of things, patient current smoker, no cigarettes per day, no BP, never had stroke, and no BP, and no diabetes. Okay, and systolic BP is 120 by 80 normal, and heart rate is 70. Now let's predict. Still patient may have heart disease, so let's change something. Total cholesterol to 120. Okay, and glucose to 100. So patient is healthy, no heart disease. So this is how our web application works. So here it is heart disease predictor. So when we enter the patient details here, so our model predict whether the patient may have heart disease or patient is healthy. First things first, we are going to build a logistic regression machine learning model here. So to build a model, we would need the data. So what kind of data we would need? We would need the patient's data set here. So once the data set is ready, then we have to do the pre-processing on that data set. And once the pre-processing of the data set is done, then we would be splitting the data set into two parts. One is the training data set and another one is the test data set. So once the splitting of the data set is done, then we would be creating a logistic regression machine learning model from the scikit-learn. So once the logistic regression model is created, then we would be training that model with the training data set. Once our model is trained, we would be testing our model with the test data set. So once the testing is completed, then our model is ready to predict the values. So once our model is ready to predict the values, we will be deploying it as a web application, as you guys have seen in the earlier part of this video. Required tools for developing this machine learning model. One is NumPy and Pandas, those are the basic ones. And third one is the scikit-learn for the models. And fourth one is IMB-learn. So I'm going to explain in the middle of the video why I'm using the IMB-learn here. Let's dive into the coding. Here I have created a heart disease prediction project folder. Here we are ready with the heart disease dataset as well. Let's open the Jupyter Lab. So our Jupyter Lab is up and running. Let's create a new notebook. So heart disease prediction. Let's import the libraries. Okay, we have imported the necessary libraries. Now let's import the dataset. Data is equals to pd dot read csv. Let me copy the path of this source dataset file. Okay, data. So here we have 4238 rows of data with the 16 columns. Okay, so first one is the gender, whether it is a male or female, and next is the age, and the next education of the particular patient, and current smoker, so whether that patient is a smoker or not, and if he is a smoker, then how many cigarettes they will smoke per day. And the next column says BP medication, so whether that particular patient is on BP medication or not, and prevalent stroke, whether that patient had stroke earlier or not, and prevalent hypertension and diabetes, and here is the total cholesterol and systolic BP and dialectic BP and body mass index, heart rate and glucose. And by considering all these things, so we are finally deciding whether that particular patient has heart stroke, yes or no. Okay, this is what our output column, and remaining 16 columns. So total we have 16 columns here. So one is the output column, which is the heart stroke, remaining 15 columns. So education, this one column out of 15 columns is not required for us. So let's drop that column here. Data drop of columns is equals to education. I don't think it makes any sense. Okay, right? Okay, I just dropped it. Let me apply in place is equals to true. Okay, so we have dropped it. Now let's print the data. So we have 15 columns now. Now let's remove the unwanted null values or missing columns. Drop NA in place is equals to true. Okay, finally data. So now the data set has been reduced to 3749 with the 15 columns. So we have gender, age, current smoker or not, cigarettes per day. So all these columns are there. So what I'm going to do here is, so the thumb rule here is, so the data before feeding it to the machine learning model, so the data should be in the numerical format. Otherwise we need to convert it into the numerical format, or we have to use the one hot encoder to convert this categorical columns into the binary columns. So here I have only two columns, right? Gender and prevalent stroke is having categorical column, so I want to convert them manually here. Okay, data of gender is equals to data of gender. Let's replace the values, male comma female with 1 comma zeros, female comma zeros. Okay, that is done. Now what else we have? So here it is converted the gender to ones and zeros instead of male and female, and prevalent stroke as well. Okay, let's dot prevalent stroke dot unique. Have no one yes. Okay, yes and no. Okay, oh, not the gender, I have to use the prevalent stroke. Okay, now we have converted from yes and no to zeros and ones. Okay, let's print the data set now. So here is the data set. Gender is current smoker, cigarettes per day, BP medication, prevalent stroke, prevalent hypertension, diabetes, total cholesterol, systolic BP, dialectic BP, body mass index, heart rate and glucose. Finally, even our target field is also having yes and no. So let's convert that as well. Data of heart stroke dot unique. Let me check the unique values first. So we have no one yes. So data of heart stroke is equals to data of heart stroke dot unique. So we already applied unique, right? So I have to replace no yes. Okay, 0 and 1s. Okay, that is also done. So now we have converted everything. Okay, here it is just yes, not capital S. Okay, now we have zeros and ones. So data pre-processing is completed. Now we have to take the consideration of gender, age, current smoker, all these 14 columns into a input data set, and heart stroke into a output data set. So let's do that. Data and score input data set is equals to data of data drop. So we have to drop the columns, right? So what is the column we have to drop? Heart stroke. Okay, and data underscore output is equals to data of heart stroke. So now we have input dataset and output dataset. Okay. Now data underscore output dot value counts. So if you see here, our dataset is very imbalanced. If you see here, the patients with no heart stroke are having entries of 3177. The people entries with the heart stroke is only 572. So our data set is completely imbalanced. So we cannot feed this data into our machine learning model. Even though if you feed this data into our machine learning model, it may not give the accurate results. So for that one, we need to do the dataset resampling. So let's do the resampling of this dataset. So what I'm going to do here is I'm going to import IMB learn here. IMB learn the oversampling import smooth. So smart. So smart, what exactly it does is it will balance, it will recreate the number of records. Right here we have the patients with 0 heart strokes are having 3177. People with the heart stroke only 572, right? So it will create the another set of data set with another sampling based upon the existing data. It will balance the both the data sets. Okay, I will show you how it is going to do. Sum is equals to smart and random state is equals to 2. Okay, we have only 2 here, right? Zeros and ones, so that's the reason random state is equals to 2 here. Okay, now data underscore input comma data underscore output is equals to sm dot fit resample of, okay, data underscore input mm, if you see here, here we have only 3177 the patient records with the no heart strokes and only 572 entries with the people with the patients are having heart stroke. If you see here, after doing this resampling with the smart, we are having both 3177 with the patients with no heart strokes and 3177 patient entries with the heart stroke. So now our data set is balanced. So that's the reason we are going to use this smart. Okay, smart, which is from the IMB learn. Okay, now our data set is balanced. Let's split our data set into training data set and test data set. Okay, data underscore input comma, okay, extends. Okay, let's import first sklearn dot model selection import. What we are going to do here is train test split, and from sklearn dot model sklearn dot linear model import logistic regression. Okay, x underscore train, x underscore test, y underscore train, y underscore test equals to train test split data underscore input data underscore output. Now test size, default size is 80% of the data set will be train dataset and 20% will be the test dataset. Okay, now we have split the dataset. Now let's feed it to the model. Model is equals to logistic regression model, model dot fit of x underscore train comma y underscore train. Okay, our model is done. Now let's model dot score of y underscore x underscore test, comma, y underscore test. So it's giving 63%, so somewhat better. What we are going to do is let's predict some values. Okay, input is equals to np dot array of let me copy it from this source dataset. uh, let's copy this one. Okay, let's change female to 0 and we have removed this column and this one no in the sense 0. Okay, and model dot predict of input. See, here it is giving the value as 1, so this patient has the heart disease. Okay, x equals to and x. Okay, so our model is predicting the values perfectly. Now let's do one thing. What I'm going to do is let's export this model. Import pickle as pk, pk dot dump of model and open heart disease model dot pickle with the right binary access. So we have exported our model. Now let's create a web application. Now open folder, here heart disease prediction, selecting the folder. So let's create a new file called app.py. Okay, and import necessary libraries, import pandas as pd and import numpy as np and import streamlit as st. Okay, now let's import the model. Model is equals to, we need pickle, right? Import pickle as pk, model is equals to pk dot load of open of, and yeah, here is the model. Copy path with the right binary access. So once we have our model is ready, and data, I need the data is equals to pd dot read csv of this heart disease one. Okay, now st dot header heart disease predictor. Okay, now we have to create couple of columns, right? So let's create those. St dot select box, choose the gender, data of gender dot unique. Okay, this is gender. Okay, and if this gender is equals to okay, let me check the unique values here. Data dot gender dot unique male female. Okay, gender is equals to male, then gen equals to 1, else gen equals to 0. Okay, male and female, we have that now. So now we have to take other things as well, right? So what are the values that we have to take? Here I'm going to print the data underscore input, data underscore input. So these are the list of the columns. I have the gender. Now I have to take the age. Okay, age is equals to st dot number input, enter age, copy. Okay, let's create all those things. Let's replace it with this. So current smoker, current smoker is patient, current smoker, and cigarettes per day, cigarettes per day. Okay, and whether he is on BV medication. BV medication, prevalent stroke. Okay, relevant hypertension. Okay, now diabetes status. Okay, now total cholesterol, systolic BP, next it could be next BMI, next heart rate. Okay, so once we have all these inputs, we have to pass it to the numpy array, right? Now input is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many we have here? 14 columns. Gender, age, current smoker, cigarettes per day, BP meds, prevalent stroke, prevalent hypertension, diabetes, total cholesterol, systolic BP, diabetic BP, BMI, heart rate, and glucose. Glucose and heart rate, comma, glucose. Okay. If I state that button predict, okay, so we have this one, model output is equals to model dot predict of input if output of 0 equals to 0, string is equals to patient is healthy, no heart diseases. Okay, else string equals to patient may have heart disease. Okay, state dot markdown of this str. Okay, fine, finally our coding is done. Let's save it, run it. Now it writes, that's cool. Streamlit run app.py. So here is the heart disease predictor web application looks like. So here we have to choose the gender. Let me choose the female. Age is 55. Current smoker, yes, 1. Okay. Number of cigarettes per day, 40 cigarettes per day. And is patient on baby medication? Yes. Patient had a stroke? Yes. Hypertension status? Yes. Diabetes status? Yes. And cholesterol is just take 200. Systolic BP is 180 and dialytic 100. BMI is 50 and heart rate 120. Glucose levels 180, 170. Let's predict. So patient may have heart disease. Okay. So if I reduce couple of things, patient current smoker, no cigarettes per day, no BP, never had stroke, no BP, and no diabetes. Okay, and systolic BP is 120 by 80 normal, and heart rate is 70. Now let's predict. Still patient may have heart disease, so let's change something. Total cholesterol to 120. Okay, and glucose to 100. So patient is healthy, no heart disease. So this is how our web application works. So here it is heart disease predictor. So when we enter the patient details here, so our model predict whether the patient may have heart disease or patient is healthy. If you like the content in this video, please like this video and subscribe to our channel. If you like the content in this video, please do like this video and share it with your friends and subscribe to our channel. Thank you so much for watching this video.